In this test, we have an organizational psychologist who's developed a test for mechanical aptitude. That is to figure out how well somebody does in mechanics, how good they are at figuring out spatial relationships and putting things together, taking things apart, and being able to go from perhaps a set of instructions on paper to actually performing the manipulations in real life. And this test is useful because if you're hiring somebody to put together things or to repair mechanical things, it's good to know what their mechanical aptitude is. And so what we have, and what he's concerned about specifically, is reliability. And the type of reliability that he's interested in at this point is test-retest reliability. And that means will if the scores, if you give the test to a person a second time, say a month later, does it still give approximately the same scores? Because for a test to be legit, it's got to be reliable. It can't depend on the weather or somebody's mood. It's really got to measure somebody's abilities, and we're going to assume that the person's abilities won't change after time. So what we want to do is we want to take a set of scores, set of people, give them the test the first time, and then maybe a month later, give them a second set of the test a second time, and see how closely they're related. So here we have 10 students in a school, and their test scores that range from 10 to the upper 40s, and we want to see to what degrees they match up. Now, just looking, it looks pretty good. Because here, same person got the lowest score for both of them. The same person got the high score for both of them. But it's not always perfect. Like here, this 27 moved to a 32, a 20 to a 17. So let's see if we can actually get a number on all of this. Now, the first thing that we want to do is create a scatter plot. Now, one of the keys to doing an Excel scatter plot is make sure you only have 2 columns in the table. Otherwise, it starts giving you all kinds of things about theories and stuff. It gets really complicated. So what I'm going to do is I'm going to copy this part of the highlight the 2 columns, Control C for copy. I'm going to put it over here, and I'm going to do Control V, and now we just have two columns in our table. Now, actually, we can tell it's not a table because there's no sort arrows. Oh, that's a lot of paste options. Let's just change it into a table. Let's go up to Insert, Table, and that looks good. Okay, now it's a table. And let's go now to insert our scatter plot. And we're going to go to Insert, and we've got Scatter Plot here. We're going to choose the first one. And look at that, we've got a pretty nice, pretty straight line there. Now let's change the title of this. Let's call this the test retest reliability. That's what we're interested in. And let's put some titles in there. So let's put a horizontal title. So this is the one that goes, this first one, our X is always the first column, so that would be score on first trial. Let's just call it a first test score. And then we can go over here and add a vertical. What did I do? Oh, look, I went into the, let's go back into the chart, add chart element, axis titles vertical, and we'll do second test score. And there we've got a good. We can, I guess, let's move this out of the way so it doesn't cover up the data. Now let's add a regression line or a trend line, and let's get the R squared also. So more trend line options. Move out of the way. So we want it linear, and we want display R squared value. We don't really need the equation here, so we'll just we'll do that. And so there we've got that. And here we, oops, let's get that there. So we've got an R squared of 0.953. Now for linear regression, we could just take out our calculator and do calculate the R that way. But why don't we use the correlation function of data analysis? So I'm going to go back to that data there. I'm going to go to insert, and now I'm going to go to data. At data analysis, correlation. Okay, and it says what's the input range. So I want my two columns here. So highlight the top rows and then shift down arrow to highlight all of them. Group by columns, labels in the first row. Now the output range, I'm going to click that. Now put the cursor down in output range because it moved up there. And let's just put it right here. And that should be good. I'll press OK. And we've got a correlation. Let's round that down. Go to Home, Numbers, Number. And we have a correlation of 0.98. So that's a pretty good. So let's see what we can conclude. Okay, so A is construct a scatter plot. Okay, we've got that. B is determine the value of R. So we can put B. And let's say we can. So they're correlated 0.98. So we're going to say the two tests are strongly correlated. And we can do comma, and then we write R in italics. So Control I, R, Control I, and then put a space before the equal sign, another space afterwards, and then 0.98, period. So that's B. And then C is, would it be fair to say that this is a reliable test? Explain using R squared. Okay, so R squared is 0.95, so that's 95%. And that means 95% of the variability in one test score is accounted for by the other. Ooh, so that means the two are picking up 95% of what they're measuring the differences of is measured by the tests. There's only like 5% of variability coming from other sources that were affected by doing it at two different times. So we can say that R, and then let's do squared. So there's several ways that we can do this. Let's see, I'll show you the way that we can do it in both. Let's just put in R2, R squared equals 0.95. So 95% of the variability in one test is accounted for by the other test. So that's very high. Now, how do we get that R squared to be a square? One way of doing it is going up into the box up here, highlighting the two, and then now you can do this in both Windows and Mac. Right-click, Format Cells, and click Superscript, and it'll just put the superscript in the highlighted to be highlighted. And so that's how we can do that. We could also have done it with the font command up here in Windows, but not in Mac. So there we have our answers. So I would say the test-retest reliability is really good with a correlation of 0.98. That's almost perfect. It's really difficult to do better than that.